But today, we're going to discuss quadratics. Now, do have to tell you a tiny story that a lot of my students were like, why are you weird? Mostly because I have the quadratic equation tattooed on my wrist. And the students were like, you just use that as a cheat sheet. I was like, no, there is a story behind it. So I've told you before in my videos, I have a brain injury from a car accident. And at the time, I was studying math, and I was helping one of my college professors as a TA. And so I was able to teach for her sometimes. And so one time I'm up at the board and I'm literally doing a quadratic. And I had no idea how to add 2 plus 2 because my brain just got wiped of all my math memory, which sucks when you're majoring in math and all of a sudden you don't know how to add 2 plus 2 or do normal math. After a while, after about a year, my memory started coming back. And so the quadratic was the first equation I remembered and always memorized. So I put it on my wrist. So that is why I have that. Not because I just wanted a cheat sheet. It's because I wanted it because it was sentimental. So let's go into quadratics. So there's a standard form for quadratics. And this is your standard form for it. A being a coefficient, x squared plus bx plus c. And we've seen this before when we're factoring, but it has to equal something, so it equals 0. Always equals 0. So, and then, so you have your A, your B, and your C, and then equaling 0. This is the standard form of a quadratic equation. And all of the solutions that solve the quadratic equation are called a root. So, if we're given something like this, where it's 3x squared plus 6 equals 8x, and they just want us to put it into standard form. They're like, just put this into standard form for us. We're like, okay, well that means it has to equal 0. So I'm just going to subtract my 8x. And now, in standard form, it's 3x squared minus 8x plus 6 equals 0. So that is the standard form of a quadratic. Super quick and easy, right? Just remember, standard form. So this is just an intro for right now, and then we'll get into more stuff in a minute. So if we're given something like this, sort of x squared minus 3x plus 5 equals x plus 5. Well, first step, because they want us to solve this. So first step, get it into standard form. So minus your x from this side and minus your 5. So 6x squared, negative 3x minus x is negative 4x. 5 minus 5 is nothing. So now that we have this, we were learning the past 2 videos to factor. We need to factor again. We're never going to not factor at this point. Like, I taught you to factor for a reason, because we have to factor. So what's in common here is our 2x, because we can take a 2 out of these and an x. And when I take a 2x out of a 6x squared, I'm left with 3x. Take a 2x out of a negative 4x, I'm left with a negative 2. Negative 2. Just negative 2. And it's all equal to 0. And I think I taught you something like this earlier, where now we're putting both of the parts we have, setting them equal to 0. So if I have 2x has to equal 0, and 3x minus 2 has to equal 0. Now, we just solve each of these to get our answers. So divide this one by 2, add 2 over here, 3x equals 2, divided by 3. So when I do that, what I'm going to get, I'm going to end up with some answers. So x will equal 2/3, and x will also equal 0. because you can mow the lawn without your shirt on, you just can't do it without your pants, so it's 0. And those are your 2 answers that will solve this equation. That's our whole goal, is we need to find the 2 answers that solve this equation. And I just did. So, a lot of this is review before we get into quadratics. I think that's why they're doing this. So let's look at this and freak people out. So you're looking at this and you're like, there is a fraction. But what did I teach you guys? You can get rid of fractions. I'm going to get rid of this fraction by multiplying the entire thing by an x. Because when I multiply an entire thing by an x, this will go away. So 3x times x is 3x squared. Negative 2 times x is 2x, or negative 2x. And then 1 over x times x equals 1. Now, let's put it in standard form. Well, minus your 1. So now we have 3x squared minus 2x minus 1. And now we have to do our factoring. And we do the factoring by this by doing a times c. And a times c in this is negative 3. Now we need factors of negative 3 that add up to negative 2. Well, we know that our 3 has to be negative and our 1 has to be positive. So when we do that, now we're going to put it back as we would here, right? We have 2 parentheses. One has a negative 3 and one has a positive 1. Well, we have this 3x here, so I'm going to put my x here because I know I have an x. But whatever this number is, the back number goes over it. Okay? So this can simplify to x, I like how I put a plus there, x minus 1. This one I'm not actually going to simplify and move that 3 out front because it'll be kind of a redundant to do. Because if you're trying to get the actual solution, I don't need to do that because I'm just going to be setting these equal to 0. So x minus 1 equals 0. X plus 1/3 equals 0. And then when we solve it, I add my 1 to this side and then minus my 1/3. And I should be getting my answers are x equals 1 and 1/3 negative. So those are my answers for this. And I'll show you why I didn't, because I showed you before when we factored, like you take this number and we're just going to move it out here. And I'll show you why I didn't want to do that. I could have. So let's say that I had moved that, right? So I had moved this over. So now it's 3x plus 1 equals 0. Well, it's going to be the exact same thing because I'm just going to minus my 1. Then I have 3x equals negative 1 divided by 3. So x still equals negative 1/3. I just took a whole step out by not moving the 3 back in front and having to divide. I just took that whole step out. That's what I usually recommend you do when you're actually trying to find the solution for these. So what if we are given x over x plus 3 minus 3 over x equals 1 over x times x plus 3. Well, I taught you guys last time to find the least common multiple or least common denominator. Well, looking at this, this has an x and an x plus 3. This only has an x. So to get rid of that, right, because that's our goal, is we have to multiply this equation by x plus 3. But here's an easier way to think of it, because I want to get rid of this fraction. So I'm going to multiply this entire thing by x and x plus 3. So when I do that, this entire one goes away. The x goes away on this one, and we're left with x plus 3. Over here, the x plus 3 goes away, and we're just left with x. Well, now let's multiply that through. So I get x squared plus, or minus, because we got a minus here. So minus 3x minus 9 equals 1. So now that I have that, put it into standard form by making it equal to 0. So minus 1. So now I have x squared minus 3x minus 10. So now we make our little factor thing over here because we need factors of a negative 10 that add up to a negative 3. Factors of a negative 10 are 5 and 2, and they have to be a negative 3, so 5 has to be negative. So then we move it, and we go x minus 5 and x plus 2. Set each of those equal to 0, and that's where we're getting our x equals 5 and negative 2. So I can just see moving those over, we're going to have a 5 and negative 2. Now the reason you have to actually check these answers is because in the bottom, right here, because these were in fraction form, because 5 plus 3 is 8, so that one works. Negative 2 plus 3 is 1, that works. As long as it doesn't have a 0 in the end, these will work. If you end up with a 0 on the bottom, then one of the answers is not actually going to work and the other one might. So you have to make sure when you're given a fraction one, you plug it back in just to make sure you're not left with a 0 on the bottom, because that's a no solution situation. So I've taught you guys the square root property before, I believe, something like that. So if I have x squared equals a, then I know that x equals the square root of a, or x equals the negative square root of a. So because you can do the opposite to get to the square root, right? So if we're given an x squared equals 16, take the square root, there's actually two answers, because it's 4 and negative 4. It's negative 4 times a negative 4 is 16. 4 times 4 is 16. Simple stuff here. So if we're given x squared equals 24, take the square root, and we split this. Split it into 4 and 6. So we have the square root of 2, so 2 square roots of 6, and we have to have the plus and minus. Sometimes it's just easier to do plus and minus. So this one will be plus and minus 2 square roots of 6. Cool. So now looking at that, let's use an equation method. So we have 3x squared minus 7 equals 13. That's a 12. 13 minus 2x squared. Okay, so first of all, have to get it into standard form. So add your 2x squared and minus your 13. So here I get 5x squared and minus 20 equals 0. Well, factor what we can out, and we know we can factor 5 out. We're left with x squared minus 4. Well, when I get to my x squared minus 4, let me see what I did. What did I do? Oh, hang on, I did it something different. Guys, I made it a little more complicated on myself when I didn't have to. Let's try it the way I did it on my paper. So I actually did this. I added the 2x squared, and then I added my 7. So I have 5x squared equals 20. Divided by 5, x squared equals 4. And then I took the square root. So it should be plus or minus 2. And if we plug that back in, it should work. So this is what I was looking at the wrong problem. That's why I was freaking myself out. So what if we're given something like this? 4x minus 5 squared equals 28. side is squared. How do we get rid of a square? Take the square root, like this. So now I'm left with 4x minus 5 equals the square root of 28. Well, we know that it's equaling the positive and the negative square root of 28. But now we need to get rid of everything and make sure we're solving for x. So what we do, I'm going to add my 5, but I can't add it to this guy. So it actually looks like this. 4x equals 5 plus or minus the square root of 28. Okay? Then we divide everything by 4. So now we have something that looks like this. Plus or minus the square root of 28 over 4. Well, we can keep simplifying the 28 because we can split it into, I did it this way, 2 and 14 and 2 and 7. So here's my pair. So now the actual answer is x equals 5. Hang on. Give me 1 second. And I'm going to answer this, and you guys are all going to hear me, like, speak here. Ah! I'm struggling. I'm recording a YouTube video right now. I'm in the middle of recording something, dude. 2 square roots of 7 divided by 4. I'm recording a YouTube video. I'll call you back when I'm done.
No.
I have to. I'm on camera.
You have to buy American chicken.
Okay, I'm coming up to visit you today.
No.
I am.
Social distancing.
I don't care. Screw social distancing. I will stand at the door.
Why are you coming up?
I go see my boyfriend.
Oh, you're gonna fuck him?
No. I'm on video. Don't say that. I'm recording a YouTube video.
You're gonna fuck your boyfriend.
Okay, I'm recording a YouTube video. Stop.
Okay, bye.
I love you. Bye. Sorry. Okay. So now that we know this, we are going to learn the quadratic formula. This is the quadratic formula. X equals negative b, or you can say opposite b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, we learned our standard form, right? Was ax squared plus bx plus c, where a, b, and c are usually numbers. So now we're just going to plug those numbers in when we're given an equation. So we have 7x squared plus 2x minus 5. Well, a, b, and c. So let's plug them in. The opposite of 2 is negative 2, so negative 2 plus or minus the square root of 2 squared minus 4 times 7 times negative 5, because the negative goes there, all over 2 times 7. So now we've plugged the numbers in. Now we just do the math. So underneath this, I now have 4 minus 4 times negative 4 times negative 5 is 20. And then times 7 is 140. And it's plus and minus. That is a terrible plus, not minus. Negative 2, and then 2 times 7 is 14. Okay, well now let's keep simplifying. 4 plus 140 is the square root of 144. And we have negative 2 plus or minus over 14. Well, we know the square root of 144 is 12. Sorry, I'm going to move up here now. So we have negative 2 plus or minus 12 over 14. Well, now that we have this is easily solvable because we're doing the plus and the minus. So negative 2 plus 12 is 10 over 14. Negative 2 minus 12 is negative 14 over 14. Now let's just simplify those fractions, and we get one of our answers is negative 1, and the other is 5 over 7. And we just use the quadratic formula to find our answers. I like the quadratic formula. It's probably my favorite formula. So let's use it again. Utilize my entire board today. So let's use it on one that won't look as pretty. Okay? I like using those ones. Ugh, my nose is killing me. So if we're given, I'm looking for my answers on here. So we're given x over 2 plus 1 equals 5/4 x squared. Okay, so we look at this, and I want to move things. I want to keep my x squared positive. So I'm going to minus my x over 2 and minus my 1. So now changing this, I have 5 over 4x squared minus x over 2 minus 1 equals 0. So I want to get rid of those fractions though, right? Nobody wants those. So looking at this, I see my common denominator is 4. So multiply everything by 4. So I'm left with 5x squared minus 2x minus 4 equals 0. So I have that. So now we're going to use our quadratic equation to solve it. So I'm going to erase this guy and we'll put the quadratic above. So x equals opposite of negative 2, so 2 plus or minus the square root of negative 2 squared minus 4 times 5 times negative 4 all over 2 times 5. Okay, so now solve it. Negative 2 times negative 2 is 4. Negative 4 times 5 is 20, or negative 20. And then negative 20 times a negative 4, ooh, is 80. And then that's over 10, and then 2 plus or minus that. So then we have the square root of 84 over 2 plus or minus over 10, right? So I'm going to erase this. So let's simplify our 84. We know that 84 can be split. How do I split it on here? I don't remember how to split it. Ooh. Sorry. 84 can be split into 4 and 21. So when we split it into 4 and 21, this is our perfect square, right? So now we have 2 plus or minus 2 square roots of 21 over 10. So now that I've done that, since I have a 2 in front of here and a 2 in front of here, I can actually simplify these because this is like a separate kind of entity here. And I don't really have to split it because they're going to be like kind of the exact same, but you know, opposite stuff. So 2 over 10 is actually 1 over 5 plus or minus, this is not how you draw a plus or minus. Plus or minus the square root of 21 over 5. Those two right here, because you can leave it like this instead of separating it, that's your answers for this equation. So, knowing that, kind of cool, right? I like being able to solve things like this. So, if we're looking at our quadratic again, I can't draw a plus and minus sign today. We have b squared minus 4ac over 2a. This right here, this little thing right here, I like how that turned into a radical. This little thing right here is called the discriminant. So this is called the discriminant. So if we can solve these by using a discriminant instead of using, instead of actually solving the entire thing. So this is the discriminant, and I spelled discriminant wrong. So if the discriminant is a negative number, the roots are not real numbers, and there is no real solution to it. If the discriminant is a positive number, then the roots are real numbers, and there are two answers. If the discriminant is equal to 0, then there's only one solution for this problem. So we're going to solve these quadratics by using the discriminant instead of putting the entire thing in a quadratic formula. So using the discriminant here, we have x squared plus 2 equals 4x. So first of all, we need to move it into standard form. So minus your 4x. So now we have x squared minus 4x plus 2. So using the discriminant, we have to use our b. So negative 4 squared minus 4 times 1 times 2, a and c. So negative 4 times negative 4 is 16 minus 4 times 1 times 2 is 8. 16 minus 8 is 8. And since it's a positive underneath the discriminant, that means we will have two solutions. This is all they wanted you to do. They don't want you to find the solutions. They want you to find out how many solutions this is going to have by using the discriminant. So we use the discriminant to find out that this equation here will have two solutions because it's positive underneath the radical. So if I'm given one like this, 3x squared minus 2x plus 3, and I'm going to use my discriminant right here, so negative 2 squared minus 4 times 3 times 3. So I have 4 minus 12 times 3 is 32. 4 minus 32, oh no, 4 minus 36, sorry, 4 minus 36 is a negative 32. And if it's underneath the radical like that, and there are no, here's the thing, there's not no solutions. There are no real solutions. So what do I mean by no real solutions? We didn't get into that in this chapter. I don't know why, and I don't know where my other stuff is. But what do I mean by no real solutions? Well, what I mean by that is that there is actually some solutions to this, but they're considered not real because we're taking out a number that we like to call imaginary. And when we take out an imaginary number, it changes that into something solvable. So looking at this, I'm gonna hang on. I know I have it in here. It's kind of pissing me off because I know I have that in here. I just want to find it. I found it. Okay. These are considered complex numbers. And complex numbers means we're given something that we can pull. Oh, I sat up way too fast when I pulled that out. We learned about rationalizing, blah, blah, blah. Complex numbers. They're right here. So this is what we consider, like it has no real solutions, but we consider this a complex number. Complex numbers mean if I'm giving this, so I'm going to erase this really quick. I'll try to explain it the best I can. So if I'm given something like this, you guys know that I've told you that usually I've told you you can't solve this, there's no solution, right? Well, there is. It's a complex number. There is a solution to it. What we have to do is we are going to be pulling something called an imaginary number out. An imaginary number is an I. When I pull the I out, I am left with the regular square root of 32. But can we simplify 32 into something? Hello. Get off my arm. Something attacking me. So 32 divided by 2, 16, and we know the square root of 16 is 4. When I take that out, I actually have 4i square roots 2. So that's my actual answer here, because I was able to pull out an imaginary number. Now the reason I'm able to do that, I will show you. So I squared, we have an I squared, and we have the square root of negative 1. Okay? I squared equals negative 1. The square root of negative 1 equals I. So, and this is the reason we need to know this. Because if we're given this, we can always pull a negative 1 squared, or the square root of negative 1 out, because you can split this and be like, well, this would be negative 1 times 3, right? So the square root of negative 1 times the square root of 3. And we can pull this negative 1 out, because we know that the square root of negative 1 equals I. So now I'm left with I square roots of 3. These are complex numbers. So looking at this, knowing that I squared equals negative 1, the square root of 1 equals I. Remember this. I love imaginary numbers. People are like, why do we need imaginary numbers? I'm like, well, first of all, if you didn't have imaginary numbers, you would not have bridges, because they have to take into account every aspect, even the imaginary ones. So if I'm given something like this, so right here I'm given the square root of negative 3 times the square root of negative 7. I need to pull out the i's. We're pulling out i's. So now I have I square root 3 times I square root 7. And now we just use our regular multiplication skills. Just multiply straight across. I times I squared. 3 times 7 is 21. Okay, what did I tell you guys I squared was? I squared is negative 1. So to simplify this, it's actually the negative square root of 21. We've simplified that by pulling i's out. I love pulling i's out. That sounded really bad, but I love pulling i's out. Not my own eyes, just imaginary numbers. That's why it sounded really bad. I like pulling i's out. Oh, hilarious. So if we're given this, square root of negative 8 over 2, first step, pull the I out. I square root of 8 over 2, simplify what we can. And we can simplify this, and 8 splits into 4 and 2. So we pull the 2 out, so 2i over the square root of 2 over 2. Well, we can simplify this even more, because the 2 divided by 2 is 1. So I'm actually left with I square root 2. This is how we're using complex numbers in our things. I love them. Okay, so multiplying complex numbers. Ooh. First of all, I'm going to show you guys a little chart. Because sometimes they'll just give you i's. So here's a chart. So we have I equals I squared equals negative 1. I cubed equals negative I to the 4th equals 1. Now we're going to get to a pattern. Are you ready for this? I to the 5th equals I to the 6th equals negative 1. I to the 7th equals negative I. And I to the 8th equals 1. So now looking at this, what do you think I to the 9th will equal? We have I to the 10th, I to the 11th, and I to the 12th. What do you think that these will equal? Well, looking at this, we know that I to the 9th is going to equal an I to the 10th is going to equal negative 1, I to the 11th is going to equal a negative I, and I to the 12th is going to equal 1. So we have this pattern. So if we're given something where they want us to find the powers of I, so we have I to the 13th. They want us to know what I to the 13th is. Well, that's easy for us right here because we know that I to the 12th is 1. So coming up, we know it would be I. But what if we're given I to the 40th? So I to the 40th power, to remember how I do this. I don't remember, guys. Now that I to the 40th power, we have to look at this, and we're like, okay, I to the 40th. Guys, I forgot how I have to do this. I know that I to the 40th is 1. Because you can make that chart. You can just keep going. Because I to the 50th equals negative 1. What about I to the negative 10th? Well, we need to make it positive. So we have 1 over I to the 10th. Which is actually 1 over negative 1. Which is negative 1. Trying to see how I do this. I'm remembering here. Honestly, I don't remember. I just make the chart every time. That's my chart. Because there are powers of I's. I power. Okay, so if we have the sum and the difference of complex numbers, so we're adding and subtracting. So if we have 5 plus 2I plus 4 minus 3I. It's the exact same thing we were just doing. We're just adding the common, what's in common? Brain. So 5 plus 4 is 9. 2 minus 3 is negative I. And we just added that, so it's 9 minus I. Adding and subtracting is pretty much the same. It's like, so the I is pretty much, it looks like a variable, but it's actually like it's a number. So I know I showed you guys earlier that we have our, I'm looking here. So we have 3 minus 4I times, when we're multiplying, 6 plus I. I like to use my boxes because they're going to come in handy. So we have 3 minus 4I and 6 plus I. So 6 times 3 is 18. 6 times negative 4 is negative 24I. 3 times I is 3I. Negative 4I times I is negative 4I squared. Well, what did I teach you I squared was? I squared is negative 1. So negative 1 times a negative 4 is actually 4. So we're going to combine these like terms and then combine these like terms because the I went away here. So 18 plus 4 is, where am I? 22. So 22, and then 24 negative plus 3, negative 21. I know I have simplified that. That's the reason you need to know your powers of i's, because I squared is negative 1. We multiplied through, made it a nice thing to combine. So what if we're going to use complex numbers to divide? So if we're given this 2 plus I over 1 minus I, we have to use the conjugate. And I taught you guys that if it's this, if there's a minus in here, we're actually going to multiply. The conjugate is the opposite, plus I. So multiply the top and the bottom by 1 plus I because it gets rid of the middle number. So getting rid of that middle number, I'll do 2 boxes here, so I want to show you that with the i's. So let's do the bottom one. Let me sneeze. Allergies. 1 times 1 is 1. Negative 1, so negative I, and negative I squared. Okay. Well, these two are going to cancel out because negative I plus I. There we go. Well, we know that I squared is a negative 1, but it's already negative, so it's 1. So 1 plus 1 is 2, so we know our bottom number is 2. Well, that was easy, right? Someone just dropped some stuff upstairs. So now let's do our second one. Where we have 2I and 1 plus I. So 2 times 1 is 2. 1 times I is I. I times 2 is 2I. And I times I is I squared. I squared we know is negative 1. So 2 minus 1 is 1. And then 2I plus I is 3I. Standard form for imaginary numbers is the number comes first, like the constant comes first, and then the I comes last. So whatever your I is, it comes after your constant instead of, you know, where it looks like this, 3I plus 1. That's not standard form. That's standard form for imaginary numbers. So that's the same thing we were doing when we were like trying to rationalize the denominator. It's the exact same thing. We're just multiplying by the conjugate, which is the opposite. So I like complex numbers. They're fun. You guys are probably like, what the crap? Why is she showing us this? That's because, what if we're given, I have to think of one, because I don't have one on here for that, and that kind of bugs me. Oh my guys, I have so much crap in here, but I can't find what I'm actually looking for, like, ever. And it's a little sad. I need to go through this really, really bad. That is not what I'm looking for. I'm getting there, I promise. Let's do this guy. Here's a good one. Here's a good one using the quadratic formula, but getting i's in it. So, we're given 4x squared minus 2x plus 1. Well, we're going to use our quadratic formula to solve this. And we use the quadratic. So we do 2 plus or minus the square root, negative 2 minus 4 times 1, all over 2 times 4. Well, we know 2 times 4 is 8 on the bottom. 2 plus or minus 2 squared is 4, and then 4 times negative 4 is 16, but negative, so square root of 4 minus 16 is negative 12. So we know right here that we have to pull out an I. So when we pull out the I, but I'm also going to pull out what I can here, so I have a 4 and a 3. So let's pull out our I and our perfect square. So we have 2 plus or minus 2I square roots of 3 over 8. Well, we can simplify both of these. Where is my answer sheet? Sorry. So let's simplify these. Well, 2 over 8 is 1 over 4. 2 over 8 is 1 over 4. So our actual answer to this one is 1 plus or minus I square root 3 over 4. So we have two answers with an I in it using the quadratic. it's really relatively simple once you like understand pies. I like complex numbers because guys, I like math. What can I say? So, oh Lord in heaven, I'm gonna have to go through my work and figure out what I want to do for next lesson. But this was quadratics and some complex numbers. We might go into complex numbers more because they are complex numbers. But that was today's lessons, quadratics and some complex numbers. Cool. I will figure out what I want to do for next lesson because I don't know yet.